So we're going to start looking at solving quadratic equations graphically. And I'm going to show you the relationship between what your factored form and your graphical form looks like. Okay, so let's say I have this quadratic equation right here. So I have x squared plus x minus 6 equals 0. And I ask you to solve this quadratic equation. And I say, go ahead and solve this guy. Okay, so solve for x. For what values of x does this equation equal 0? You're probably going to pretty quickly tell me that, okay, I can find two numbers that multiply together to give me -6 and add together to give me +1. What are those two numbers? Those two numbers are, they're going to be -3. There'll be -3 and -3 and +2. Okay, or sorry, the other way around. +3 and -2. That makes more sense. Okay, so when I factor this, I'm going to get x plus 3 times x minus 2. That's going to give me x squared plus x minus 6, and that's going to equal 0. So then when I go to solve this, I know that x plus 3 equals 0 and x minus 2 equals 0. Therefore, x would have to be -3, and, x could be 2 as well. Okay, so -3 and 2 are my answers. I would say that this is my solution, right? I would also call these my roots. I would also call these my zeros. Okay, so all these words really are describing the same thing. And I could also say that these two numbers, -3 and +2, when I graph this equation, they're also going to be my x-intercepts, because on my graph, you'll notice that this really what it means is that when x equals -3, like my coordinate on my graph would be x equals -3 and y equals 0. Okay, and this guy here, what this is describing is that x would be 2 and y would be equal to 0. So these are the two coordinates that hang out on my graph. And that means that they're going to end up somewhere over here. So here's like -3 and 0, and then here's, 2 and 0. So that's why I call these my x-intercepts, because this is where the graph crosses the x-axis. Okay, that's what this means. This is where the graph crosses x-axis. Okay, that's what that's referring to. And I call this my zeros because, well, that's where my equation equals 0 for x equal to -3 and 2. That's where my equation equals 0, but it's also where, again, my graph crosses the graph, and both of my coordinates give me y equals 0. Okay. And then I also use the word roots to describe this. So I say that these 2 points are my roots. They're the roots of my graph. And of course, this is a solution to the equation that we have. So that's where all this language is coming from. And you can see it. So what I'm going to do is I'm going to go into Desmos and I'll show you. So if I open up Desmos and I graph that same equation, so y equals x squared. Whoops, that's not what I was supposed to do. Here we go. There's my generic quadratic function, or my parabola, y equals x squared. And then if I have y equals x squared plus x minus 6, okay, there's your graph. So you can see in Desmos, if I click on these points, right, you can see it right there, that the coordinates -3, 0 and 2, 0. Those two coordinates are on the graph. and that's where the graph crosses the x-axis. Okay, and that will happen every single time. So we can do a couple more just to make sure that this is super clear and super obvious. Let's take a look at x squared minus 9x. So x squared minus 9x equals 0. So now if we go to solve this guy, again, I can factor it. I can pull the x out because it's common in both. I'll get x times x minus 9 this time equals 0. And when I look at this, it's kind of like I have x plus or minus 0 times x minus 9. That's really, it means the same thing, right? I don't have to have this here. This is just kind of as a side note, but what I'm saying here is that my values of x, this equation will equal 0 when x is equal to 0. And also when x minus 9 equals 0, which means that x would be equal to positive 9. So on my graph, that means that my coordinates are going to be when x equals 0, so does y. Okay, and when x equals 9, y also equals 0 there as well. So that these 2 points, so this is right here, this is at the origin, this is 0, 0. And then 9, 0 might be over here somewhere, right? 9, 0. So I would say that these are the roots of my graph or my equation. So roots of x squared minus 9x. And then I would also call these zeros of this equation. And I would say that they're also the x-intercepts. And if I go back into Desmos and I graph this, you're going to notice the same sort of thing happened where you're going to see that graph crossing those 2 points. So let's try it out. So we have y equals x squared minus 9x. Okay, it looks like that. So when I zoom out, there we go. Okay, this is what this graph looks like. And again, I can click on these points and there it is, 0, 0 and 9, 0. So this is how your solution, you solving for those, for the value of x, this is how it's related to the graph. This is always going to happen repeatedly again and again. Let's say you have a situation where you have something that you can't really factor, right? Let's say you have something that can't be factored. What would that look like? So here I gave you 2 examples that can be factored. You can solve them this way. It's no big deal, right? But what if you can't factor? What if you have something that looks like this? So let's say you have x squared minus x minus 3 equals 0. Okay, when I factor that, well, I can't factor it. If I try to factor it, you're going to quickly find that there are no such numbers that exist. When I try to multiply some values together to get negative 3, or add together to get negative 1, it's not really possible, right? Okay, so here, this is when I would use the quadratic formula. So I can use the quadratic formula here, no big deal. So remember what the quadratic formula says. It says that x equals negative b plus or minus the square root of b squared minus 4ac. And I'm going to divide the whole thing by 2a. So in this example, a is equal to 1, b is equal to negative 1, and c is equal to negative 3. And when I plug this into my quadratic formula, I end up getting x equals negative b. Or not b, sorry. I was going to replace b with the number negative 1. Plus or minus the square root. Now I have negative 1 squared minus, I have 4 times 1 times negative 3 over 2 times 1. So then x is going to equal positive 1, okay, because these negatives end up canceling each other out, right? And then I have plus or minus, I got the square root of 1, and again, I have a negative here and a negative here, so those will also cancel. I'll end up adding. That ends up being 4 times 3, which is 12, over 2. So I end up getting 1 plus or minus the square root of 13 divided by 2. Okay, so I have two roots here. I have two zeros. I have one that is 1 plus the square root of 13 over 2. Okay, and we can approximate that. So the square root of 13 is, well, the square root of 9 and the square root of 16. The square root of 13 is in between there. So it's definitely going to be between 3 and 4. So this is approximately, what, like halfway, a little over halfway. So let's just approximate this to 3.5. Okay, so I could say that this is approximately 1 plus 3.5 over 2. Which is the same as, so I'll say, actually I can just put a little dot over top that says approximately, which is the same as 4.5 divided by 2. And 4.5 divided by 2 is the same as 2.25. Okay, so this is approximately 2.25. And then my other solution is where I'm subtracting. So I have 1 take away root 13 over 2. That will give me approximately 1 take away 3.5 over 2, which ends up being negative 2.5 over 2. And that results in, so half of that would be negative 1.25. So that means that approximately, if I start converting these to decimals to just single values instead of leaving it in this like radical form, I have two zeros, one where x is equal to 2.25 and one where x is equal to negative 1.25. So my two coordinates for this equation, this x squared minus x minus 3 equals 0, it looks like this. I have 1 point where I have 2.25, 0, and my other x-intercept is going to be at negative 1, 2.5, and 0. Okay, so again, these are my zeros. These are my x-intercepts, okay? And I also call these my roots. Okay, and in the example that we're doing here, because we've jumped to decimals now, we've come out of that radical form, these are just approximations. So they're not exact, they're just approximately. Okay, so they're approximately this value and then this value. And if we go back into decimals and we graph this, this is what you're going to see. You're going to see these decimal numbers on the x-axis, okay? So let's graph it. We have y equals x squared plus x minus 3. There we go. And when I click on these, there you have it. So my approximation isn't perfect, right? I think I had, what, negative 2.5 or something? Hang on a second. Oops. Okay, so I have negative 2.3 and positive 1.3. Negative 2.3 and positive 1.3. Negative 2.3 and positive 1.3. Ooh. Oh, I made a mistake. I said x squared minus x, and when I graphed it, I did an addition sign. Hang on, let me go back here. Let's clean it up. One sec. Okay, sorry. So when I actually graphed this, I think I accidentally entered the wrong middle term, right? I said it was addition, but it's actually not addition, it's subtraction. Sorry, that was my mistake. So that's why I was like, hey, something looks a bit off here. There we go. That's better. Okay. So we have positive 2.3 and negative 1.3 approximately. Okay? That's where your roots and your zeros hang out. So now that you've had a chance to maybe just reflect on this a little bit, maybe go back, rewatch some of the video, make sure you're clear on what's what. We can start going through the 4.2 math lab where it says assess your understanding. If you want to work through the first few, like the A, B, C, D before that part on page 284, 285, I've just gone through some of it in this video, but you're more than welcome to do that just to make sure you're clear. And the other thing that I just want to draw attention to before I let you go is also the discriminant. Okay, let's quickly talk about the discriminant before we move on, just so you can see what's happening. When I look at these three examples, you can see that if I go back and I look at the discriminant in each one, okay, so remember the discriminant is, it's this part of the quadratic formula. It's the b squared minus 4ac. So if I go back and I look at the b squared minus 4ac, just in this equation, if I look at b squared minus 4ac, I know I have two roots. I know my graph goes like this, right? It goes like that, okay? That means that b squared minus 4ac should be greater than 0. That means, that I'm adding, like I have my negative b, I'm adding and subtracting something, right? There's a value here, which is the square root of b squared minus 4ac. That's why I'm getting those two solutions. And in fact, that's happening in all three examples, because in all three examples, I have two roots everywhere, right? Here I've got two roots. In this example, I've also got two roots that look like this. And then in this one, I've also got two roots. These roots aren't as clean. They're a little bit, these are approximations, right? So this one here is like right here and right about here. Okay, so my graph goes like this, okay? There you have it. So you'll notice that I'm getting those two real roots because b squared minus 4ac is greater than 0 in all three examples. You may run into situations where that's not the case. I'm going to let you find those by working through the math lab in section 4.2. Do use your Desmos app, because in a lot of the questions there, it's asking you to use technology. And then in a couple cases, it's saying don't use technology. But definitely use the Desmos app to confirm, check your work, all that good stuff. Okay, good luck.